There is a place on this earth where the ocean has no end, no land, no boundary, no mercy. Just water, stretching in every direction for over 10,000 miles, moving in an endless, violent circle that has been building force for 30 million years. This place has a name, and if you've heard it, you already know to be afraid. The Drake Passage, 56 degrees south latitude, a narrow corridor between the southern tip of South America and the frozen continent of Antarctica, only about 500 miles wide. That doesn't sound terrifying until you understand what fills those 500 miles. Wave heights that regularly reach 60 feet, winds that punch the water at 100 miles per hour. Currents are so powerful they carry 6 times the combined flow of every river on Earth, and they never stop. Not in summer, not in winter, not for anything. But here's what nobody talks about. The Drake Passage doesn't just kill ships. It does something stranger and more disturbing than that. It changes people. The sailors who cross it and survive, and not all of them do, come back different. They talk about it in whispers, about the things they felt out there, the things they thought they saw, about a silence inside the roar that was somehow louder than the storm. This is their story. And it is also the story of the most dangerous stretch of open water in the history of human exploration. But before we talk about who survived, we need to talk about who didn't. In September of 1905, a 3-masted wooden bark called the Defies was making the westward run around Cape Horn. She was a good ship, experienced crew. The captain had made this route before. What he didn't know, what nobody could have known, was that a convergence of low-pressure systems was forming to the southwest. A meteorological event so rare it didn't even have a proper name yet. The ship entered the Drake Passage on a Tuesday morning. By Thursday, she had disappeared from the face of the Earth. No wreckage was ever found. No bodies, no cargo, no lifeboats, nothing. A ship of 2,000 tons and 28 men simply ceased to exist in the Drake Passage, and the sea gave back nothing, not even an explanation. That's the first thing you need to understand about this place. It doesn't just destroy, it erases. To understand why the Drake Passage is so violent, you have to go back in time. Not hundreds of years, not thousands, millions. 34 million years ago, the continent of Antarctica was attached to South America. Warm ocean currents wrapped around the southern hemisphere the way they do in the north, looping, circling, and exchanging heat between the tropics and the poles. Then the continents drifted apart. The gap between South America and Antarctica opened, slowly at first, then wider and wider over millions of years, and something catastrophic happened to the ocean. The current that had been looping around the globe suddenly had nowhere to stop, no landmass to deflect it, no barrier to absorb its energy. It found an opening, and it began to flow west to east through that gap, and it began to accelerate. Over millions of years, that current grew and grew. Today, oceanographers call it the Antarctic Circumpolar Current. It is the largest ocean current in the world. It carries more water than any other current on Earth by a factor that almost defies comprehension. And its narrowest, most concentrated point, where all of that force is squeezed through the tightest gap in its path, is the Drake Passage. Think about what happens when you put your thumb over a garden hose. Now imagine that garden hose is 10,000 miles long, and it has been building pressure for 30 million years. That is what the Drake Passage is. And that's not even the worst part. The worst part has a name. Sailors call them simply the 40s, the 50s, and the 60s. Roaring 40s, furious 50s, screaming 60s. These are the latitude bands of the Southern Ocean, named not for their coordinates, but for the wind. In the Northern Hemisphere, continents break up air circulation. They create weather patterns, pressure systems, and temperature gradients that slow things down and redirect energy. But below the tip of South America, there is no land. There is nothing to interrupt the wind. And so it builds. The roaring 40s, 40 degrees south latitude, is where wind speeds regularly exceed 50 miles per hour, and the seas run in long, heavy swells that that roll unbroken for thousands of miles before they find the Drake. The furious 50s, 50 degrees south, where those swells have grown taller, steeper, and faster. Where storm systems don't pass through in days, they circle, they stay, they feed on the ocean beneath them. And the screaming 60s, 60 degrees south, the southern edge of the Drake Passage, where the wind and the Antarctic circumpolar current and the freezing air off the polar ice shelf collide in a system of violence so sustained and so powerful that it produces wave formations that modern physics still struggles to fully explain. The technical term for what those waves can create is a rogue wave, a single wall of water that appears without warning, not the result of a steady build-up, but a constructive interference event where multiple wave systems align and combine into one monster. In the Drake Passage, rogue waves have been documented at over 100 feet tall. 100 feet! That is taller than a 10-story building, moving at 40 miles per hour, and it appears without warning, without radar signature, without any physical sign, until you look up and realize the horizon has become a wall. But here's what rogue waves in the Drake do that rogue waves almost nowhere else do. They don't just break over ships, they lift them, completely out of the water. Sailors who have survived describe the sensation of weightlessness, of feeling the ship rise beneath them at a speed that defies gravity, followed by the vertical fall on the backside of the wave. The structural stress of that impact has broken steel ships in half. And yet for 400 years, human beings kept sailing through it anyway, because there was no other way. Francis Drake didn't actually sail through the Drake Passage. That's one of history's quiet ironies. The passage is named after him because when his ship was blown south of Cape Horn during a storm in 1578, his involuntary drift proved that the two oceans connected south of the land. He didn't choose it. The sea chose it for him. The man who first intentionally navigated the passage in something like controlled conditions was a Spanish sailor named Francisco de Hoces, 20 years before Drake, which is why in some countries the Drake Passage is called the Mar de Hoces, the Sea of Hoces, a detail most history books omit. But what no one disputes is what the passage represented for the age of sail. For 250 years, from the late 1500s until the opening of the Panama Canal in 1914, the Drake Passage was the only reliable route between the Atlantic and Pacific Oceans. If you were a merchant ship, a naval vessel, a supply ship, or a whaling boat, if you needed to move between the two great oceans of the world, you went through the Drake, or you didn't go at all. And so, generation after generation of sailors sailed to the bottom of the world, looked at the sky, checked the wind, said a prayer to whatever god they believed in, and pointed their bow south. Some of them made it, many of them didn't. In the centuries before modern weather satellites, before steel-hulled ships, and before diesel engines that could push against a headwind, trying to sail westward through the Drake Passage in a wooden ship was considered by most experienced sailors to be among the most dangerous things a human being could voluntarily attempt. The westward passage was the nightmare. Eastbound, with wind at your back and current beneath you, a skilled crew might cross in 2 or 3 weeks. Westbound, fighting against the Antarctic circumpolar current and the prevailing winds simultaneously, the crossing could take months. Months. There are records of ships that spent 90 days attempting to round Cape Horn, making no progress, running low on food and fresh water, and having crew members die of scurvy and exposure before turning back and sailing the long way east, all the way around the world, because it was faster. That's how powerful this place is. It was sometimes easier to sail completely around the globe in the opposite direction than to fight your way through 500 miles of the Drake Passage. Now I want to tell you about a man named Thomas James. In 1631, James was an English sea captain sent by Charles I to find the Northwest Passage, the mythical shortcut through Arctic Canada that explorers had been searching for since the discovery of the Americas. He never found the Northwest Passage, but the journal he kept during his voyage became one of the most important and least known documents in maritime history. In his journal, James described something that sailors in the Drake Passage would describe again and again over the following centuries. Something that modern psychologists have finally given a name. He described the feeling that the sea was alive, not metaphorically, not poetically. He wrote, with the blunt, practical language of a 17th century navigator, that there were moments on the water, during storms, during long nights, during periods of unbroken violent weather, when the ocean seemed to have intention, when it seemed to be trying to communicate something, when the line between the external world and his own mind became unclear. He attributed it to God. Later sailors attributed it to madness, or fatigue, or fear. Today we know it as something else. Psychologists who study isolation and extreme environment survival call it third man syndrome, a phenomenon documented in explorers, solo sailors, mountaineers, and Antarctic researchers. The vivid, persistent, often comforting, or sometimes terrifying sense of a presence, an unseen companion, a consciousness that isn't yours. In the Drake Passage, it happens with unusual frequency. Solo sailors who have made the crossing report conversations with people who weren't there. Mountaineers who have survived avalanches in the Andes describe a calm voice that guided their decisions. Ernest Shackleton himself, the greatest survival story in Antarctic history, wrote about the fourth man who seemed to march beside his exhausted team during their crossing of South Georgia Island. What is it? Where does it come from? The neuroscience is incomplete. We know that extreme stress, prolonged sleep deprivation, and sensory overload, all of which occur simultaneously in a severe Drake Passage crossing, can produce auditory and visual phenomena. We know the human brain, faced with the possibility of its own death, sometimes generates companions, splits the consciousness to manage what the whole mind cannot. But here's the part that still doesn't have a clean scientific explanation. The presence that these people encounter is almost always calm, almost always helpful, almost always tells them the right thing to do. What is the mind protecting itself from by creating this? What is out there in the Drake Passage that is so overwhelming, so fundamentally threatening to human consciousness that the brain invents a guide rather than face it alone? We don't fully know. In 1968, a British man named Donald Crowhurst entered a solo sailing race around the world. He was not the most experienced sailor. He was not the best equipped. But he was ambitious and he was desperate. He had bet his business, his house, and his family's financial future on winning the race, and he could not afford to withdraw. He entered the Southern Ocean. He encountered the fringes of the Drake, and then something broke inside him. He began to falsify his logbook, inventing positions, fabricating mileage, and creating a fictional voyage around the world while drifting in the Atlantic and waiting for his competitors to lap the globe so he could join the finish. He sat alone on a boat in open water for months, writing increasingly disjointed philosophy in his journals, trying to construct a new theory of the universe that would make sense of what he had done and what he had seen. When his boat was found drifting in the Atlantic, there was no body, only his journals. Over 25,000 words of them. The last entry was dated July 1st, 1969. And then, like the Dumfries Shire in 1905, a ship and a man simply ceased to exist, and the sea returned nothing. Crowhurst never reached the Drake Passage, but the Southern Ocean, the approach and the knowledge of what waited ahead had done what the Drake had done to sailors for 400 years. It had reached inside a person's mind and changed something permanently. Here is what we know about the Drake Passage's body count, and here is why we probably know far less than the truth. The Cape Horn region, which includes both the Drake Passage and the waters immediately surrounding the Cape, is believed to have claimed over 800 ships in the age of sail. 800. From the late 1500s to the early 1900s. But that number comes from records, from ship logs, insurance filings, merchant reports, and naval documents. And those records have enormous gaps because a ship that disappeared completely left no record at all. No one to report back, no wreckage to identify, no evidence of the final hours. Maritime historians believe the true number could be 2 or 3 times higher. What that means in human lives is not calculable. What it means in terms of cargo, history, and lost knowledge is equally uncalculable. How many scientific samples from early explorers sank in the Drake? How many diplomatic dispatches, works of art, architectural blueprints, seeds and plants from newly discovered lands? How many letters did people wait their whole lives to receive, slowly waterlogging at the bottom of the Drake Passage while the people who sent them were already gone? The sea keeps all of it. In 2006, a team of deep-sea researchers using remotely operated vehicles surveyed a section of the Drake Passage seafloor for the first time with high-resolution sonar. They found what they expected: an ancient, cold, sediment-blanketed plain. They also found something they did not expect. Scattered across the seafloor, at depths of over 3,000 meters, they identified anomalies that matched the profile of wooden-hulled ships. Not one, not two. Multiple sites spread across a survey area that covered less than 1% of the Drake Passage floor. Less than 1%. What is resting in the other 99? The Drake Passage is not just a graveyard, it is a laboratory. Modern climate scientists have come to understand that the Antarctic circumpolar current, the engine that powers the Drake, is one of the most critical systems in global climate regulation. It transports heat, carbon, and nutrients across all 3 major ocean basins. It connects the Atlantic, Pacific, and Indian Oceans in a single circulatory system that oceanographers call the Global Ocean Conveyor Belt. If the Drake Passage did not exist, or if the current that runs through it were to significantly change speed, the consequences for global temperature would be felt within decades. Monsoon patterns over India and Southeast Asia, drought cycles in sub-Saharan Africa, ice melt rates in Greenland, sea level rise across every populated coastline. It all connects here. Every Atlantic hurricane gets a portion of its energy from the thermal systems that the Antarctic circumpolar current regulates. Every coral reef in the Pacific is influenced by the nutrient exchange that happens in the mixing zone at the edge of the Drake. This is the paradox of the Drake Passage. The most hostile and inaccessible environment in the accessible ocean, the place that killed 800 ships and God knows how many men, turns out to be one of the places that makes the rest of the planet livable. There are researchers who spend their careers trying to understand it, who sail into the Drake in modern research vessels equipped with satellite communications and storm-rated hulls, and still, sometimes, find themselves holding on with both hands in seas that exceed their instrument's calibration range. One of them is a woman named Dr. Sarah Perkey, an oceanographer at the Scripps Institution of Oceanography in California. Perkey has made multiple crossings of the Drake as part of long-term climate monitoring research. She has described the crossing in terms that will be familiar to anyone who has read the old sailors' journals. She says the Drake Passage has a personality, not in the mystical sense, in the observational scientific sense. It is rarely what you expect. It can be flat and grey and deceptively still in the morning, and by afternoon it can be running swells of 30 feet and worsening. Or it can roar for 3 days straight and then, without explanation, drop to near calm for 12 hours in the middle of the crossing. The instruments tell you the physics. They don't tell you what it feels like to stand on a research vessel in 40-knot winds with Antarctic ice visible to the south, understanding intellectually exactly why the ocean is doing what it's doing, and still feeling, in the oldest, most animal part of your brain, that you are in the presence of something that does not care about you at all. Not hostile, not malevolent, simply indifferent. And of all the things the Drake Passage makes you feel, she says, indifference is the most frightening. In 2010, a woman named Roz Savage became the first person to row solo across the Drake Passage. Not sail, row. A 23-foot boat, no motor, oars. She spent 26 days in the Drake Passage, rowing into and across one of the most violent ocean environments in the world. She survived 2 capsizes. She survived 3 equipment failures. She survived nights when the temperature dropped below freezing and the spray from breaking waves coated everything on deck in a layer of ice. When journalists asked her afterward why she did it, what compelled a human being to voluntarily sit in a 23-foot rowboat in the Drake Passage, she gave an answer that is more profound than it might first appear. She said, "Because I wanted to know what I was made of." This is the psychology that the Drake Passage has always produced in the people drawn to it. Not suicidal recklessness, not ignorance of the danger. Something more complicated, something that psychologists who study extreme environment exploration call the edge experience, the particular human hunger for the absolute limit of what a human being can survive. The Drake Passage is one of the few places still left on Earth where that limit is real, where the ocean is genuinely capable of killing you regardless of your equipment, your experience, or your preparation, where the gap between survival and death is still, to some meaningful degree, a matter of chance. Most of the planet has been tamed, mapped, made predictable. The Drake hasn't, and that, ironically, is why certain people cannot stay away from it. The future of the Drake Passage is written in ice. As global temperatures rise, the Antarctic ice shelf is changing. The West Antarctic ice sheet, which borders the southern edge of the Drake Passage, is losing mass at a rate that has accelerated significantly in the last 3 decades. As that ice melts, fresh water enters the Southern Ocean, altering the salinity, and therefore the density, of the water that feeds the Antarctic circumpolar current. Climate models disagree on the precise outcome. Some project a slight slowing of the current, which would have cascading effects on global heat distribution that scientists are still working to fully model. Others project no significant change in speed, but dramatic changes in the seasonal variability of the Drake's storm systems. What oceanographers generally agree on is this: the Drake Passage in the year 2100 will not behave exactly like the Drake Passage today. The ocean that killed 800 ships is changing, and we don't yet know what it's changing into. There is also this: as Arctic sea ice continues to decline, the Northwest Passage, the mythical shortcut that Thomas James and countless explorers searched for through centuries of failure, is becoming navigable. For certain months of the year, large commercial vessels can now sail through Arctic Canada. The Panama Canal can handle most modern cargo ships. The Drake Passage, for the first time in human history, is no longer strictly necessary. And yet, ships still cross it. Researchers, adventurers, expedition vessels, Antarctic supply ships, the occasional cruise liner full of passengers who wanted to see penguins and ended up gripping handrails in 60-foot seas. Because the Drake Passage is not just a route, it is a threshold. There are people who feel the need to cross it for the same reason people have always crossed it. Not because it takes them somewhere they couldn't reach another way, but because of what the crossing itself does to a person, what it strips away, what it reveals. The age of sail is over, but the Drake Passage is not. It is still out there, right now, tonight. The Antarctic circumpolar current is still running. The furious 50s are still blowing. Somewhere in those 500 miles of dark water, something is happening that no human eye is watching and no instrument is recording. A convergence of wave systems, a submarine canyon redirecting the current, a school of bioluminescent creatures lighting the base of a 60-foot swell from below. The Drake Passage is alive. It has been alive for 30 million years. It will be alive long after every ship that ever crossed it has rusted to nothing on the seafloor. There is one more thing you need to know. In 2019, a research team from the British Antarctic Survey deployed a series of deep ocean sensors across the Drake Passage floor. The sensors were designed to measure temperature, salinity, and current speed, standard oceanographic instruments. But when the data came back, one of the sensors had recorded something anomalous, a pressure event, a single pulse lasting approximately 4 seconds that registered at a magnitude inconsistent with any known geological or oceanographic process. Not an earthquake, the seismic profile was wrong. Not a submarine avalanche, the sediment data didn't match. Not a ship, nothing was in the area. The team published a brief note about the anomaly in their data summary. They flagged it as instrument error, probable. They moved on. But one of the researchers, a junior member of the team, who has since declined to be publicly named, kept the data file, kept looking at it, showed it to colleagues in other disciplines. Nobody could explain it. The Drake Passage has been studied for decades. It has been sailed for 4 centuries. Its physics are, in broad outline, well understood. And yet something happened on its floor in 2019 that the best instruments we have recorded and the best minds we have consulted cannot explain. In a world where almost everything has been mapped and categorized and filed away, that is a remarkable thing. The ocean has secrets. The Drake Passage has more of them than most. 800 ships on the bottom, millions of years of unrecorded weather, a pressure event with no explanation, and the memories of every sailor who crossed it, who stood at the rail in the dark with the wind screaming, and felt, for reasons they couldn't articulate then, and science can only partially explain now, that they were not alone. The Drake Passage doesn't just want you dead, it wants you to understand something first. What that something is, nobody who has crossed it has ever been quite able to say. Maybe that's the point. Some thresholds aren't meant to be explained, they're meant to be crossed. And the Drake Passage has been waiting for 30 million years in the dark water at the bottom of the world for whoever is brave enough or foolish enough or hungry enough for truth to point their bow south and sail in.